Hey everyone, welcome back. Today is day 6 of my 30-day FAANG grind, and I'm solving 6 to 10 LeetCode problems daily, explaining them on video, and sharing with all of you on YouTube. I'm Divya, by the way. I've interned at Massachusetts Institute of Technology, where my area of focus was in statistics and machine learning. Right now, I'm at top 0.3% on LeetCode, and like most of you, I'm a big fan of LeetCode, and I love to code. Previously, we have already covered sliding window, two pointers, prefix and suffix based problems. And we have also tackled problems based on strings and problems based on stacks. Today, it is all about binary search, which is one of the most powerful and versatile techniques in coding interviews. In this series, we'll go beyond just finding a target and we'll solve problems based on rotated arrays, lower and upper bounds scope, and binary search on answers, and much more. Before I begin, if this content is helping you out, please smash that like button, hit subscribe, and share it with someone who is grinding too. Let us begin. The problem that we're tackling today is the code 162, which is find peak element. In this case, we have been given an array of positive and negative integers. It can contain either positive or negative or both of those, okay? And we have to determine the peak element in this array. I assume that you have went through the description of this problem, so I will not waste time on that. This is the constraint. Let us go to the dashboard and we'll try to investigate and find an optimal solution for this problem. Cool. What will the brute force for this problem? We have been given nums, okay? And we have to find peak element. Peak element is such an element which is greater than the immediate value on its left and immediate value on its right. For example, in this case, 3 is the peak element. Why? It is greater than 2, it is greater than 1, correct? The brute force approach will require us a linear traversal starting from left, going on till the right, and at every index, we compare it its value to the left value and to the right value. And if it is greater than the value present at the left as well as to the right, then that element will be the peak element and will return the index of that element. Okay, cool. So here are several cases that we have to deal with. Before that, there is a thing, and it is stated in the problem at index 0 and at index 1, any value that goes beyond the scope of the array towards right or towards the left, it will be assigned a value of minus infinity and minus infinity. In that case, 1 is greater than any value on its left, which is minus infinity, and but it is smaller than 2. Okay, in this case, 1 at the end is greater than the value on the right. Why? Because it is minus infinity, but it is not greater than a value on the left, which is 3. But what if we just have a value something like 1 and 2? In that case, what will be the peak element? The peak element will be 2 because 2 is greater than the value present on the right, which is minus infinity, although it is not visible in the array, but it is stated in the problem. And 2 is also greater than the value present on the left, which is 1. Okay. Similarly, if we have something like 3 and 2, in that case, the peak element will be 3 because 3 is greater than the value present on the left, which is minus infinity, although it is not shown in the array, but it is stated in the problem. And 3 is also greater than 2. So 3 will be our peak element in this case and will return the index 0. Okay. So these two were the base cases for checking the first element and the last element. And then we can scan and compute for the remaining elements as well. Okay. Now, first of all, there can be a duplicate elements in our array as well. Okay, so there are a few cases that we need to take care of, and I have explained those cases with the help of diagram just to visualize how our computation will come to be. Okay, in the first case, what if all our elements are equal? Okay, this pink line, it represents the magnitude, some arbitrary value x naught, and we can see every single element in this range is equivalent to x naught. So in that case, what we'll do something what we'll see, okay, in the code. Now, there are two different cases over here. What if we have something like this? What we have our value, which is increasing in linear order. In that case, what we'll do, we'll find the left pointer, which will point to the left hand. Then we'll find the right pointer, and using L and R, we'll find the mid. And if we found the mid, I'll compute if mid is greater than mid minus 1. If that is the case, if the value present at mid, if it is greater than mid minus 1, it means our array values are increasing in nature. Okay, in that case, peak will never lie behind that thing. Instead, peak will always lie ahead of it. Okay, in this diagram, peak is here, correct? In the similar manner, in this diagram, if we take a look at this part, our left is here, our right is here, our mid is here, and our mid minus one is over there, right? We again see that mid value, it is greater than mid minus one, which means our peak value must lie on the right of it, or towards top of it, or ahead of it. In this case, visually, it lies over there, right? Let us look at a different case. In that case, we have some element over here. Oh, remember, by the way, this array is sorted, okay? Oh, this array is not sorted, right? Is it? Let us just go to the problem. Okay, so this array is not sorted, which like makes our problem much more easier. Okay, anyway, so in this case, let us look at this example. This case would have been come into effect if our array would have been sorted, but since our array is not my bad, this case would have come into effect if our array was rotated, but since our array is not rotated, so we'll not address this case. Okay, instead we'll just focus on this case. In this case, left is over here, right is over there, and our mid is over here, right? What do we see? We see that the value of mid, it is greater than mid plus one, or value of mid, it is smaller than mid minus one. If such is the case, in that case, we will be pretty certain that the peak will lie above mid or below mid, or on the left side of mid. Okay. In this case, it will lie to the left side of mid, which is somewhere here. Okay. So using all these three visualizations, excluding this visualization, which will be for the case where array is rotated and sorted, and we have to find the peak. We'll not consider this for this case for this problem. Okay. So using these different cases that we saw over here, we will try to code this problem up and we'll see the optimal solution. Okay. So let us come back to code. We have two variables, left and right, both are pointing towards the end. Then we bound them in the while loop, compute the mid over here, and then we ask, hey, the current mid value that I'm standing at, is it greater than the immediate value on the left? And is it greater than the immediate value on the right? If that is the case, then that will be the peak element. In that case, please return the mid value. Otherwise, I'm going to ask by looking at these two cases over here, hey, is the mid value, hey, is it greater than mid minus one? If that is the case, if value of mid, if it is greater than mid minus one, it means peak will lie on the right side of the array. If value of mid, if it is greater than mid minus one, in that case, peak will lie on the right side of the array, in this case over here, and in this case over there, okay? So if mid value, if it is greater than mid minus one, in that case, please move the left pointer to mid plus one. Otherwise, if the value of mid, if it is smaller, if it is smaller than mid minus one, or if the value of mid, if it is greater than mid plus one, in that case, our peak will lie to the left of mid. Okay. As we can see over here, if the value of mid, if it is smaller than mid minus one, value of mid, it is smaller than mid minus one, or we can just put on either of those two cases, not necessarily we will have to put or, but just I'm showing you, okay? This one is optional. Or if the value of mid, if it is greater than mid plus one, if the value of mid, if it is greater than mid plus one, in that case, the peak element will lie on the left of the mid. In that case, what we're gonna do, we will shift our right pointer or high pointer to mid minus one at this place, and this will be our sample space to explore, okay? That is what we have done over here. And this is the last case where what if every single element is equal, such as in this case. So in that case, we'll just move our left pointer by mid plus one and we'll compute, okay? And once our entire array is exhausted, if we did not find a peak element, we'll simply come out of this loop and we'll return minus one, and that will be the answer. But if we do indeed find a peak, that will be identified at this spot while we are dealing with the mid value and comparing the immediate value on the left and immediate value on the right at the mid value. And if that statement is executed, we'll return mid from here. Okay, cool, cool. So the time complexity of this problem will be logarithmic, and the space complexity is bounded with constant. So it will just be constant because we are just declaring two variables. All right, so that was all there was to this problem. I hope you enjoyed my explanation. Let us go to the LeetCode dashboard where we'll try to submit the solution for this problem and see how it goes. I've already copied and pasted my code. So let me just run it down and see how it goes. That's the code, and this is the solution. Let us see if it passes. And as you can see, it does passes all the test cases. So yeah, that was all there was to this problem. I hope you enjoyed it. If you have any questions, please feel free to ask me in the comment section. I'll be much more happy to answer you there. Till then, take care. Bye bye.